12, 16, valid palindrome 3. So for this question, we are giving a string s and an integer k, so we're going to return true as if s is a k palindrome. And let's first try to understand what is a k palindrome. So a string is a k palindrome if it can be transformed into a palindrome by removing at most k characters from it. So let's just check the first example. So we're gonna remove b and e. So after remove this b and e, so what's gonna happen is it's gonna become a c d and c a. So this is a palindrome, right? Because we remove at most 2 characters, so this is okay. It is a palindrome, so it's gonna be true. And for the second example, let's just check. This is AA from the left to the right side, and this is BB. Yeah, and here this is a B. Maybe we're gonna remove this B. We are not sure, but what if we remove it? So it's gonna be AB, AB, A, B, A, and it is a palindrome, right? So it means, yeah, we're gonna remove at most 1 characters, and then the 3s gonna become a palindrome, and this 1 character gonna be less than or equal to k, because k is the maximum value. So if we are checking the example carefully, it seems we can solve the problem by using interval DP. It means if we are giving us a string from the left and right side, we're gonna check if they are the same character. For example, this A and A. So we're gonna move the left pointer and the right pointer. And we should be careful about this is not 2 pointers. It is the dynamic programming. Yeah. So before our range is from the left to the right. So if they are equal, we're gonna shift it in the middle. So, but what if they are not equal? So if they are not equal, we're gonna choose these areas. So let me use another color. So we're gonna choose these areas. Maybe it is inside this one, or we're gonna choose these areas. We're gonna choose the next one. Maybe it is inside the next one, and we're gonna choose the maximum of the 2. Yeah. So we're gonna choose the maximum of the 2 rings. Yeah, so this is how we're gonna solve the problem. Now let's just start coding. We're gonna use a case as this is a dynamic programming problem, and we're gonna prepare 2 pointers. So if normally I should be less than or equal to j. So if I is more than j, so definitely it means it's not possible. So we're gonna return a 0. So what if I equal to j? Yeah. So for us, we are going to check what's gonna be the longest palindrome. So for example, if the longest palindrome, if the length of the string is n, if the longest palindrome is L, so if n minus L is less than and equal to k, it means we're gonna return true, otherwise it's gonna be false. Because n gonna be the length of the string, and L gonna be the longest palindrome. Yeah, because we can calculate the longest palindrome by using dynamic programming. Yeah, so this is for calculating the longest palindrome. If they are equal, so we're gonna return a 1. So this is for example, we're gonna have some characters. Let's just use maybe ABA. Yeah, this is equal. This is equal. If the L and I and J goes to the middle, goes to B, and if they are equal, so we're gonna check. Oh, this character must be valid. So it's gonna return a 1. And what if they are equal? So we're gonna return a 2. So 1 plus 2 is gonna be 3. So 3 is gonna be the longest palindrome. Yeah. Now we're gonna check if Si equal to Sj. So we're gonna return Fi plus 1 and J minus 1 plus 2. So otherwise, if they are not equal, so we're gonna choose the maximum of Fi plus 1 to J and Fi J minus 1. And finally, we just need to return f0 to length of the string minus 1. And what is the length of the string? Yeah, so we're going to use the length of the string minus the longest palindrome, and this value should be less than and equal to k, because k is the maximum. Yeah, because k is the maximum characters we can remove. Yeah, so here, this length of the string minus the dynamic programming minus the longest palindrome. So it means how many characters we can remove to make up it a palindrome. Yeah, so this means at least we're gonna remove some characters to make it a palindrome, and this number should be less than or equal to k, because k is the most characters we can remove. Yeah. Now let me just run it and submit it to check if it works. As you can see, it works and it's pretty fast, and the time complexity is I times j. So basically it means it is 1000 times 1000. Yeah, because for this I, it is from the left side, it can go to the right side, and this j, from the right side, it can go to the left side. Yeah, so basically we're going to use 1000 times 1000 for the time complexity. Actually, it might be smaller, but we're going to use basically we're going to use 1000 times 1000 as our time complexity. Thanks for watching. See you next time.